Hello friends, myself Nagesh Nahate, Assistant Professor, PG Department of Chemistry, Sri Shivaji Art, Commerce and Science College, Akotpur. Today we are going to learn about some of the important questions in inorganic chemistry occurs in NET and SET examination. So in every year NET and SET examination occurs and there are certain questions asked in these examinations from inorganic section. So today we are going to discuss some of the questions. So look at this first question which is asked for 2 marks. The term symbol for a particular state of an atom is 3d3. The values of L, S and J for this term are respectively. And the 4 options are given. Let me explain what is term symbol. The term symbol is the different states of energy levels associated with an atom, and it is shown by the formula 2s plus 1 Lj, where 2s plus 1 is the spin multiplicity, L is the total orbital angular momentum quantum number, and J is the value of L plus S. So here you can see 3 is the spin multiplicity, that is 2s plus 1. Therefore, the s value is 1, then 2s plus 1 becomes 3. Therefore, the s value is 1. Then the j value is also given 3. It means we know that j is equal to L plus s. If s is equal to 1, then j is equal to 2. Therefore, j is equal to 3, therefore L is equal to 2, therefore L plus S is nothing but 3, therefore S is 1 and L is 2. So the correct option is B, where L is 2, S is 1 and J is 3. So this is very simple question. Next question is, which of the following complex ion has a magnetic moment value same as TiH2 by 63 positive? In this question, TiH2 by 6 complex is given, which is a tripositive and it has a D1 system. So the number of unpaired electron is 1, and we know that for one unpaired electron the magnetic moment is 1.73 Bohr magneton. So among these 4 given complexes, which ion has the same magnetic moment as TiH2 by 6? So for this we have to know the D configuration of each metal ion. So in case of first complex Mn dipositive, it has a D5 configuration and it is a low spin complex. So the all the electrons are filled in T2g orbitals. So in T2g 5 and Eg 0, therefore in T2g orbital one unpaired electron is present, so that the spin only magnetic moment value is 1.73. In case of second complex, iron complex, oxidation state of iron is 2, but the configuration is D6 and it is a high spin complex, so there is no spin pairing and the configuration is T2G4 Eg2, where n number of unpaired electron is 4 and its magnetic moment value is 4.90. Similarly, in third and fourth complexes, all these two complexes are high spin complexes and their magnetic moment values are not same as manganese complex. So the correct answer is option A, which has magnetic moment 1.73 bm, which is equal to the titanium complex. So it is very again easy question. Moving towards the next question, which of the following orbital is most destabilized in trigonal bipyramidal geometry? So in this question, it is asked that which orbital has most destabilization. We know that the energy is inversely proportional to stability. More is the energy of orbital, less will be the stability. That is, more is the energy, more is the destability. So in this example, dz square orbital has highest energy, therefore it is the most destabilized orbital in trigonal bipyramidal geometry splitting. So this is again simple question, but you require crystal field splitting pattern to know. We generally know tetrahedral and octahedral splitting, but sometimes square pyramidal, trigonal pyramidal, bipyramidal geometry is also asked. Next question is asked about the oxidizing agent. Which of the following can act as an oxidizing agent? So we know that complexes having less than 18 electrons are oxidizing agent as they oxidize others. They want electrons, so they oxidize others and they self reduce by accepting the electron to become stable. And we know that 18 electron complex is more stable than rest of the complexes. So here if you see the total electron count, manganese has 17 electron, iron is already 18 electron complex, cobalt is 19 electron complex, and iron is again 19 electron complex. So among these four complexes, the first complex is less than 18 electron, so it is act as a oxidizing agent for other complexes. Moving ahead, the next question is about the type of reaction mechanism. The reaction given is an example of. So there are four options: isomerization, nucleophilic substitution, inner sphere electron transfer, and outer sphere electron transfer. To know the mechanism of this electron transfer reaction, we should know the basic knowledge of ligands, complexes, and metal ions. So if you see the first complex, it has a chlorine ligand, which is a bridging ligand. And whenever bridging ligand is present in a complex, it acts as a bridge between the two complex for electron transfer. It facilitates the electron transfer. And whenever bridging ligand is present, there is a inner sphere electron transfer takes place. So the given reaction is an example of inner sphere electron transfer reaction because of the presence of chloride ligand, which act as a bridging ligand. Then the last question is match the following class of boranes with their examples. So different types of boranes are given and their formulas are given. You have to identify the types of boranes. We know that closoborane has a formula BnH2n plus BnHn plus 2 or BnHn2 minus. Nidoborane is BnHn plus 4, where n is the number of hydrogen, number of borons. Arachnoborane has formula BnHn plus 6 and hypoborane has formula BnHn plus 8. So if you see the options, the closoborane is B10H10 2 minus, which fits the first formula. Then nidoborane has third example B9H13, and arachnoborean has B8H14. So the correct option is A2, B3 and C1. Thank you.